The fourth objective is related to the hard sandwich soil layer. For the hard sandwich soil layer using the higher mode analysis. So there are various literatures which are available on the higher mode. So higher mode basically the phase velocity which is having the higher magnitude as compared to the fundamental modes. So various study has been focused on the detection of the deeper layer, which is some of study they are showing that we can use the resolution of the inverted VS profile, and some study are showing we need to have the higher modes for the represent the average dispersion curve. So we have used this finite element simulation to generate the condition of the high VS layer at intermediate depth, where the top and bottom layers are having the low VS layer. So this model 2 and 3 generate the scenario of the high VS layer, hard sandwich layer in between the two layers, and model 1 is just used for the validating the responses which we are getting, the property which we have assigned to the soil model. So in the case of the high VS layer at the shallow depth at 2.4 meter depth, the higher mode is not completely separated. So it is the case of the mode mixing phenomena. In case of the high VS layer at 7.2 meter depth, this mode is completely separated with the mode separation. So we have inverted the fundamental mode for both the cases. So here in case of mode mixing phenomena, as we cannot clearly identify the phase velocity and frequency corresponding to the higher mode, so we can observe that we have observed that this higher mode is showing the depth at which the high VS layer is placed. In the mode separation phenomena, we have estimated the lambda by 2 corresponding to the higher mode, which is giving the much better approximation with the depth of the high VS layer. We have also used the same information of the soil layer configuration, and we have calculated the fundamental and higher modes using the surface wave partial derivative using the implicit function theory. So here we have observed from the analytical solution the fundamental modes is approaching towards this first higher modes, and in the case of the high VS layer at 7.2 meter depth, it is well separated. So as this surface wave partial derivative is work on the linear convergence, so the exact magnitude we have not compared, but we are getting the similar trends for the solution which is obtained from the finite element simulation as well as the surface wave partial derivative equation. So we have seen how the higher modes is going to detect the high VS layer. For that we have simulated the model with the 6 number of layers. As the sequence of the layer is increasing, the VS is also increasing. So the layer 6 is having the high VS value. So here in these two models, this high VS layer is introduced between the low VS layer, and in both the cases when we have generated the dispersion image, so it is indicating the higher modes. So the lambda by 2 corresponding to this value is denoted is verified the depth at which this layer high VS layer is introduced. Further, we have performed the test at the sites in our campus, where we have performed the downhole seismic test and the MASW test. So from the we have performed the test in forward and reverse direction to capture the wave field. These are the dispersion curve from these two forward and reverse shot. So here we have observed the high indication of the higher modes. So we have analyzed it in large views. As previously we have estimated the VS and the depth corresponding to the higher mode. We have followed the similar strategy. So here we can see the lambda by 2 corresponding to this are showing this layer is having the comparatively higher layer as compared to the other depth. So this higher mode analysis is define the conditions like what are the conditions where we can utilize this analysis for the high VS layer estimation. We have shown that from the irregular soil profile there is a mode mixing and mode separation phenomena for the case of the like sandwich soil layer also. So when there is a mode separation, so it will observe for the VS layer at the greater depth, and in mode mixing it should have obtained from the results of the shallow depth of the high VS layer. So we have obtained the some inaccuracy in the prediction, which is ranging from 0.5 to 1 meter.